Okay, so now we move to chapter 6, discrete random variables. Okay, so first we will introduce. So discrete random variables. Okay, so I think you know what are discrete variables. We have discussed discrete variables in length in the previous chapters, isn't it? Okay, so now what we are gonna do here is we are gonna go into discrete random variables. That's the new word here. So what's a random variable? A random variable is a variable whose value depends on the outcome of a random event. Can you see? So it's completely random. Okay, the range of values that a random variable can take is called its sample space. I think I think you might have heard of these terms previously. Sample space. Okay, so a random variable is a variable whose value depends on the outcome of a random event. So you need to have an event. Okay, so for example, what kind of a random event can we have? There can be many types of events. So the easiest example that you can understand here, tossing a dice. You know there are how many outcomes? There are 6 possible outcomes. So the range of values that a random variable can take is called its sample space. So in the case of the dice, the sample space would be 1, 2, 3, 4, 5, 6. Okay, a variable can take any of a range of specific values. Can you see here? Can you see the variable? Anyway, you know, we are talking about discrete variables. So discrete variables can only take specific values. It can't take all values in a given range, isn't it? So in a given range, the discrete variable, the variable can take any of a range of specific values. The variable is discrete if it can take only certain numerical values that we understand, right? You know, discrete variables can only take certain values, right? You can't take all the values in a given range. That is continuous. If you can take all the values in a range, that's continuous. But if you can take only specific values in a given range, that's discrete. Okay, the variable is random if the outcome is not known until the experiment is carried out. So basically, before you toss the dice, you can only guess. You can't be certainly sure what you're gonna get until you toss the dice. Okay. And then the next one, a probability distribution. A probability distribution fully describes the probability of any outcome in the sample space. Okay, so this is really important because we will be working a lot with probability distribution. Okay, so what's the probability distribution? It fully describes the probability of any outcome in the sample space. Okay, so the probability distribution for a discrete random variable can be described in a number of different ways. For example, take the random variable capital X. Can you see? They have the random variable. Okay, we have taken the random variable as capital X. And what's the random variable? Score when a fair dice is rolled. Can you see? We are also taking the same example. And by the way, when it comes to these random variables are written using uppercase letters. For example, capital X, capital Y. Do you see? So when it comes to random variables, like naming the variable, we name the variable by using capital letters. So this is the convention. Okay, the particular values that the random variable can take are written using equivalent lowercase letters. For example, simple x or y. Do you see what's going on here? The naming. Okay, so here capital X is the score when the fair dice is rolled. And then what will simple x be? The simple x will be the values that this random variable takes. So what are the simple x values? So if you are rolling a dice, what are the values of simple x? It should be 1, 2, 3, 4, 5, 6. Can you understand? So that's why they say, so using a probability distribution table. Okay, so if you use the probability distribution table, just take a look at this. This is the table. Okay, so you have many types of representations. The probability distribution table, I think, is clear to you, right? You can see here simple x. So what does simple x represent? Remember, the simple letters represent the numerical values, particular values. Simple x values are 1, 2, 3, 4, 5, 6 when you toss the dice. And then can you see probability capital X equals simple x. What is capital X? Capital X is the score. It's the name. Remember the capital letter just describes the name of the variable. So capital X is the random variable. The score equals simple x are these values you have on top. Do you agree? So how does the probability work? In a dice, you know, the dice is normally, we consider it to be fair, right? Each and every side has an equal chance of being selected. So which means to get 1, you have a chance of 1 out of 6. To get 2, you have a chance of 1 out of 6. So you see 1 over 6. So each and every outcome has an equal chance of being selected. Do you agree? Okay, so this is called the probability distribution, this table. And that's really important. You need to be able to build probability distribution. Okay, and then another one, another type they have given here is something called probability function. Okay, so what's a probability function? So you can see here probability. So P means probability. Inside bracket, capital X equals simple X. Who is capital X now? As I told you, capital letters denote the name of the variable. So capital X is the score of the die. So the score equals simple X means the value. Okay, so they are saying here probability capital X equals simple X is, now you know here, I think you understand in the dice, all these outcomes, do they have the same probability or do they have different probability? All the outcomes have the same probability. So they write the probability is equal to 1 over 6 and then put a comma and then you write for what x values you have this certain probability. So I have this 1 over 6 probability for what x values? I have the 1 over 6 probability for x value 1, 2, 3, 4, 5 and 6. Can you see? So this is another different way of representing this. So this is called a probability function. Okay, and then the final one using a diagram. I think you can see it's a probability table, x against probability. X values are 1, 2, 3, 4, 5, 6, and you can see the y values, the probability. I think you can see the probability doesn't change because for each and every outcome it's 1 over 6. So all the lines are drawn to a height of 1 over 6. Can you understand? So these are the three ways that you can actually what? Denote that you can show a probability distribution. We use these different words, a probability function, a probability distribution, and using a diagram. Okay, so these are the ways we represent these kinds of experiments and data. Okay. All right, and then one final thing about this table, okay, that you need to know is when it comes to a probability table, you must know that the total probability in the table always adds up to 1. The total probability will always add up to 1. So that's one way to check whether you build the table accurately. If the table is properly done, the total probability will always be 1. Okay, so that's really important. Okay, so then let's move to exercise 6A, question number 4. Okay. They say here we'll start with question number 4. A discrete random variable, capital X, has the probability distribution shown in the table. Find the value of K. How do we attempt to find the value of K here? You can see here simple X, the probability values, the random variable values are given by the simple letter. Capital X is the name of the variable. Okay, we just said the random variable is capital X. So, and the probability for each and every outcome is given. So when x equals 1, the probability is 1 over 3. When x equals 2, probability is 1 over 3. When x equals 3, there's an unknown probability k. And when x equals 4, there's a probability 1 over 4. How do we get the k value? We know that the total probability should add up to 1. So we can write here 1 over 3 plus 1 over 3 plus k plus 1 over 4. All of this adds up to 1. So how much is the addition? 1 over 3 plus 1 over 3 plus 1 over 4. That gives us 1 over 3 plus 1 over 3 plus 1 over 4 is 11 over 12. And then k equals 1 minus 11 over 12, which is 1 over 12. So k is 1 over 12. Then I'll move to question number 5. The random variable capital X has a probability function. Can you see? So it's a probability function is given to you. Show that k is 1 over 10. But how do you understand work with probability function? Okay, so probability function is and the probability table are Like they are representing exactly the same thing. So when it comes to this probability function, you saw how we represented it previously, right? So the probability function and the same thing you can show it even by using a table. Okay, it shows the probabilities for the certain x value. So all you have to do here is maybe we'll build the table, shall we? So simple x. Let's go for the simple x. What are the simple x values we have here? What are the simple x values we have here? 1, 2, 3, 4. So make the table for 1, 2, 3, and 4. And probability capital X equals simple x. So how does this work? When x equals 1, how do you write the probability? Now you can see here the probability is given. It's not just a figure value they have given. They have given the probability in terms of x. Can you see it's kx? So then how do you fill the first value? The first probability. The first probability value you have to fill it by using x as 1, which means what? It's k into 1. K because x value is 1. So k into 1 means the probability for the first x value is k. When x equals 2, what's the probability? K into 2, which is 2k. And when x equals 3, it is k into 3, which is 3k. When x is 4, it's for k into 4. Therefore, this is 4k. Can you see how we build the table? Okay, and now from this table, you can get the value of k. How do you get the value of k? So what is the rule here? You know, total probability adds up to 1. So you can take the total probability k, 2k, 3k plus 4k, isn't it? Plus, yeah, 3k plus 4k. All of this will add up to 1. The total sum of the probabilities must add up to 1. Okay, so 4 plus 3, that's 7, 8, 9, plus 1k, that's 10k. Equals 1, k equals 1 over 10. Okay, so this is the value of k, and they are asking us to show that k is 1 over 10, which means you need to, since it's a show that question, make sure you show sufficient working. Okay, so k is 1 over 10. Okay, so next let's move on to question number 6. The random variable x has a probability function. Probability, so capital X is the random variable equals simple x. Remember, simple x are your values, okay? Okay, so the probable distribution is given here. So for x values, now the simple x values, what are they? So simple x values, so you can see here it's 1, there's 3, there's 2 and 4. And you can see this probability distribution is divided into 2 sections. So kx for x value is 1 and 3, k times x minus 1 for x values 2 and 4. Can you see? So let's actually quickly build the probability table. So simple x values are what? 1, I'll go in order, 2, 3 and 4, right? Then probability that the random variable is equal to the simple x value. So what do we use when x is 1? When x is 1, you have to go to the respective person. When x is 1, it's kx. And remember, you don't just write kx here. You have to replace the relevant x value. So when x is 1, it's k into 1. So that's k. When x is 2, to which person do I go? I can't use the first one because the first kx is only for 1 and 3. When x is 2, I have to go for the second line. Can you see? When x is 2, so it's k times x minus 1. In this case, x must be replaced by 2. So k times 2 minus 1. Who is k times 2 minus 1? K times 2 minus 1 is, that's 1, right? So 1k. Basically, it's again a k. When k is 3, when x is 3. So when x is 3, you go to this value over here, right? When x is 3, so it's k into 3. That's 3k. When x is 4, when x equals 4, you have to go to this line over here, right? Go to the relevant place. K times 4 minus 1. 4 minus 1 is 3. So 3 into k, that's 3k. Okay, so this is the probability distribution table. Okay, all you got to do now is to find the value of k. How do you get the k value? You know the rule, the sum of the probability or the total probability always adds up to 1. So k plus 3k plus 2k equals to 1. So 5, 6, 7k. Isn't it? Sorry, 3k plus 3k. 6, so 3 plus 3, that's 6, 7, 8. 8k is equal to 1, which gives me k equals to 1 over 8. Do you agree? And then we have found the value of k, that's done. Moving on to part B, they ask you to find the probability. So this is part A. Part B, they're asking you to find the probability that x is greater than 1. So capital X, the random variable value, is exceeding 1. So where do we have find the value is greater than 1? So greater than 1 means which x values do we go for? The value, the random variables. In the random variable capital X, what are the values? What are the simple x values which exceed 1? Obviously, in the table, you can see the simple x values are 1, 2, 3, 4. So, which of them is greater than 1? It's 2, 3, and 4. Do you understand? So, probability x greater than 1 means this includes the probability x is 2, plus it includes the probability x is 3, plus it includes the probability that x is equal to 4. So, probability x is equal to 2 is k, probability x equals 3 is 3k. Probability x equals 4 is also 3k. So adding everything together, 3k plus 3k, that's 6k plus 1, that's 7k. And k value we have found now as 1 over 8. So answer will be 7 into 1 over 8, which is 7 over 8. So the answer is 7 over 8. Okay, so moving on to question 7, the discrete random variable capital X has a probability function. So 0.1 for x value minus 2 minus 1, beta for x value 0, 1, and 0.2 for x value 2. Find the value of beta. So I could draw a quick sketch of this table. The simple x values are minus 2, minus 1, 0, 1, and 2. And the probabilities for minus 2, it's the probability is 0.1. For minus 1 also, for x value minus 1 also, you can see the probability is 0.1. For x value is 0, the probability is, when x is 0, the probability is beta. When x value is 1, the probability is beta. And when x value is 2, it's 0.2. Can you see? All right, so got this. Now, how do you get the beta value? So what is the rule? We know that the total probability will add up to 1. That's the rule. So 0.1 plus 0.1 plus beta plus 0.2 is equal to 1. Total probability is equal to 1. So 0.1 plus 0.1 plus 0.2 is 0.4. Beta plus beta is 2 beta equals to 1. So 2 beta equal 1 minus 0.4 is 0.6, which gives me beta is 0.3. Okay, so that's done. Then in part B, there's a construct a table given the probability distribution of x. So in this case, what you do is you make the table and you actually give the two beta values. So you draw the, I drew this table in part A to actually make it easier for us to use it. So if you can do part A without actually drawing this, that then and immediately write the probabilities, just immediately write this line by looking at the probability function, you can go ahead. Anyway, in part B, the table, in this case, you will draw the completed table for part B, which means what? You will draw the part B table along with the beta value. So x value minus 2, minus 1, 0, 1, and 2. Probability capital X equals simple x 0 0.1, 0 0.1, beta is 0 0.3, 0 0.3, and 0 0.2. So this is the probability table, the probability distribution. Okay. Okay, then the last part. Okay. Find the probability x is greater than or equal -1 and less than 2. Probability x is greater than or equal -1 and less than 2. Okay, so which x values? Now remember on either side, the random variable, you have the simple x value. So simple x value should be greater than or equal -1 and smaller than 2. So these are discrete variables. The equal mark being here, not being here makes a difference, right? So greater than or equal -1 means, can I include -1? Yes, x equal -1 is included. Plus greater than -1 means, what do I go? I can go greater than -1. We can go for 0, isn't it? Probability x is 0. I can also go probability x is 1. Agreed. 0, 1. Can I go for probability x is 2? No. Why? Because they say x is smaller than 2. It does not have smaller than or equal to. So x is less than 2, which means 2 should not be included. X equal -1, 0, and 1. So x equal -1, probability is 0.1, x equals 0, probability is 0.3, x equals 1, that probability is 0.3. So answer is 0.7. So this is the probability. Is this clear? Okay.